Hello everyone, this video is going to be over questions 1 to 7. That's the first 7 questions in this paper, the first 50 marks, first half of it. And the reason for making these longer videos is that it takes a lot of time to create a thumbnail and upload each individual video, and by putting more in one video I save time, of which there's not a lot left until the exam. So anyway, in the description will be the timestamps and the topic of each question and the number of marks if you are interested. So let's get right to it. So it says, answer all 11 questions. You must write your answers in the space provided. So on and so forth. Okay, so this looks like it's a graphing question. Just noting this down. So it says, on the axis below, sketch the lines with equations. Y is 8. Okay, so if y is constantly 8, there will be a straight horizontal line, because any y equals a constant will give you a straight horizontal line at that level, because y is that level for any x whatsoever. So if I'm using my ruler here, and I try to get a straight line going, I should get the notes on right, because I actually need to draw. Okay, pretend this line is horizontal. This is going to be our y equals 8. And secondly, y plus x equals 6. Okay, so when you have y plus x is equal to a constant, and of course this is going to be 8 at the intersection. When you have y plus x is a constant, you're going to get an intersection on one axis at that constant, and an intersection on another axis at this constant. Because no matter what, they always have to add up to this constant, so you will get a smooth sloping line down like this. So this is y plus x equals 6. Because anyway, it also rearranges to y is 6 minus x. If you plot that, you would also get an y-intercept of 6 and the slope of -1. And finally, y is 3x minus 4. So we know there's the y-intercept of -4. And so there would be and it's positive 3 gradient. So it would intersect here somewhere like, okay, when x is 0, or when y is 0, x would be 4/3, which, yes, I suppose it would be about here. So we've got these 3 lines here. This is y equals 3x minus 4, because there's a positive gradient of 3 and a y-intercept of -4. Okay, so show by shading the region R which satisfies y is greater than or equal to 3x minus 4. Okay, firstly, if it's greater than, then it cannot be beneath this line. So I'm going to scribble out everything beneath this line. Y is equal to 3x minus 4. Then y plus x must be greater than 6. Okay, so if this is y plus x is equal to 6, and you move the x to the other side, so y must be greater than 6 minus x. You know, it has to be above this line as well. So we can shade out anything below, because we know it's not going to be our target. And x must be greater than or equal to 0, so only on this half of the graph, the right half. So we can shade out everything here. And finally, y must be less than or equal to 8, so it cannot be above this line. Finally, I'm just going to write R here, which is our region that we wanted so desperately to find on the graph. Alright, so I consider that question done, despite the artistic challenge. Alright, question 2. This question is, well, it's talking about the roots of quadratic equations, so I'm fairly certain it would be to do with alpha and beta. It says find the set of possible values of p. Alright, so what I'm thinking is it's going to be some kind of interval or a range of numbers, like from A to B. Alright, so I've just taken a note of the timestamp. Let's get into this question. It has unequal real roots. So we must find the set of possible values of p. Right, so I'm not really sure where to start. We know that alpha plus beta must be equal to minus 4p over 1 because of the sum of roots theory, and that alpha beta must be 9. So what can we do with this information? So we know it has unequal roots, meaning that alpha must not be equal to beta. Okay, so what I'm going to try first is solving using the quadratic equation for x in terms of p. So we'll have x is negative b, so b is plus 4p. So minus 4p plus or minus the square root of b squared minus 4ac. So that would be, for it to be b squared minus 4ac, 16p squared. And a is 1, c is 9, so it would be minus 36 all over 2a, all over 2. Alright, so what I'm thinking this is related to actually is the discriminant here, because if this is less than 1, then we have the invalid values of p. So we just need to solve the inequality in order for our roots to be real. We need to solve the inequality. 16p squared minus 36 must be greater than or equal to 0. So if 16p squared minus 36 must be greater than or equal to 0, and we can scale this down, p squared minus, well, 36 divided by 16 would cancel out to 9 over 4. P squared minus 9 over 4 must be greater than or equal to 0, or in this case, p squared must be greater than or equal to 9 over 4. And of course, 9 over 4 looks like 3 over 2 squared, so we know what must happen here is that if you quickly sketch out the quadratic graph, p squared will look like this, where this is p and this is p squared, then must be greater than or equal to 9 over 4. So we know that's going to be in these directions. So p must be greater than or equal to, well, if you take the square root of 9 over 4, it's plus or minus 3 over 2. So p must be greater than or equal to 3 over 2, and p must be less than or equal to negative 3 over 2. But wait, there's more. So we know that the roots are unequal, and if p were to be 3 over 2, then we would get x squared plus 6x plus 9 is equal to 0. This would factorize out to just x plus 3 squared, at which point both roots are negative 3. And additionally, when it's minus 6px, it is the same functionally as x minus 3 squared. And in this case, both roots would be positive 3. So we know that it cannot actually be equal to So p cannot be equal to plus or minus 3 over 2 because it would have equal roots in the case that alpha would be equal to beta would be equal to plus 3 and minus 3. Therefore, our final possible values of p, or range of possible values of p, would be this set, not including this. So if we want to give our thing in set notation, it would be p is in the real numbers such that p is strictly greater than 3 over 2, or p is strictly less than negative 3 over 2. Right, so I'm going to consider that question done. Okay, next we have this question about a function here. Fx is 3x squared plus 6x plus 7. Given that fx can be written in the complete the square form, so the a part is just asking us to complete the square, and the b part is asking us to do some differentiation, it seems like, because we're finding the value of x for which 1 over fx is a maximum, and the minimum value of 1 over fx. Interesting. So I think that 1 over fx will be a maximum where the absolute value of fx is closest to 0, because that would make the largest number, right? Or we'll deal with that later. For now, let's just try to complete the square, because I think stuff will become obvious to us once we work it out. So this is 5 marks, quadratic equation, and differentiation. Right, so we have fx is 3x squared plus 6x plus 7. And okay, so the first thing I'm going to do is factor out this 3. So it's 3 times x squared plus 2x plus 7 over 3. Alright, and then we can complete the square on the thing that's inside. So it's plus 2x, meaning that it would be x plus 1 squared minus or plus some constant, so 3 x plus 1 squared. And of course, the term coming from this squared, the constant term, would be just a 1. So we can subtract 1, and then plus 7 over 3. And you evaluate these two together, and you will get positive 4 over 3. So 3 times x plus 1 squared plus 4 over 3. And we multiply the 3 back in, or we should really label the questions. We multiply the 3 back in to get 3x plus 1 squared times x plus 1 squared plus 4. And this is our form completed the square. So this is not asking us to write it in this form, but we want to find the value of a, b, and c. So we can put our answer in the box that a is 3, b is 1, and c is 4, corresponding to these numbers in the completed square form. Right, hence or otherwise, find the value of x for which 1 over fx is a maximum. Okay, so this looks like it's just a regular quadratic equation, and the thing is, when fx is at a minimum, it will still be above 0. So fx's minimum is the lowest that it goes, the closest to 0 that it goes, and so therefore the greatest value of 1 over fx, which would be a quarter of 1 over 4, because when this squared term, where x is -1, and this squared term becomes 0, that's the minimum. The squared term can only ever be 0 or greater. So when it's 0, that's the minimum. X must be -1. So again, saying that the minimum value of x would be equal to c, and the value of x at the minimum would be equal to -b or -1. So when fx is at a minimum, because fx, it only goes to the positive real numbers, the maximum of 1 over fx is achieved. So, in conclusion for this argument, the value of x for which 1 over fx is a maximum would be the value of x for which fx is at a minimum, which would be -b, which would be -1. So 3bi would be -1, and 3bii, meaning the maximum value of fx would be the 1 over the minimum, or the minimum of fx, which would be 1 over 4, as 4 is our constant c. Alright, so I'm going to declare this question done, and we are going to move on to the next one. Alright, so this question seems to be about arithmetic sums. So I'll take a note of the time. It's 17:45. Question 4, 8 marks, series. Right, so we want to find out, or we want to show rather, that the sum from 1 to n of where each term is 3 times the index -4 is equal to n over 2 times 3n minus 5. Alright, so for this question, we're going to use my favorite formula for the sum of an arithmetic series, which would be n multiplied by the average term of the series. So that would be the first term plus the last term over 2. So it's the average of all the terms in the series, because they all go up by equal amounts. So when you multiply the average of the number of terms in the series by the number of terms in the series, then you will find the result for the sum of that arithmetic series. So sum to n is equal to n times a1 plus an over 2, and of course a1 is equal to, well, where r is 1, 3 times 1 minus 4, which is equal to 3 minus 4, which is equal to -1, and an would be equal to 3n minus 4. So if we substitute a1 as -1 and an as 3n minus 4, we get that the sum to n of this arithmetic series must be n multiplied by minus 1 plus 3n minus 4 over 2, which would be equal to n multiplied by, rearranging here, 3n minus 5 over 2. And of course we want to show that it's n over 2 times 3n minus 5, so we just move the 1 over 2 factor outside to get n over 2 times 3n minus 5. Okay, so it says, hence or otherwise evaluate 50, the sum from 11 to 50, the 11th to 50th term of 3r minus 4. Okay, so if it says something like hence or otherwise, you're allowed to do either building on the work you've already done or a completely new method. And actually what I think I'm going to do is just do a completely new method using the sum to n terms that I have detailed here. So, or in actual fact, let's do the hence method, because that would be more likely to be on the mark scheme. So anyway, what I think they're expecting you to do is express this as the sum from r is 1 to 50, subtract the sum of r is 1 to 10, so that you are left with just 11 to 50 and not the first 10 terms. So the sum from r is 11 to 50 of 3r minus 4 is equal to the sum from r is 1 to 50 of 3r minus 4. And from this is subtracted the sum of r is 1 to 10 of 3r minus 4. And we can evaluate this using the formula we already have. So this is equal to 50 over 2 multiplied by 3n minus 5. So 3 times 50, 150 minus 5, 145. Or in fact, let's write this out as the substitution to show that we know what we're doing. So it's 50 over 2 times 3 times 50 minus 5 minus 10 over 2 times 3 times 10 minus 5, which would be equal to, well, 50 over 2 is 25, and of course this is 145, minus 10 over 2 is 5, and then 3 times 10 minus 5 is 25. And this would be equal to 25 times 140, which, if I consult my calculator, it would be 3,500. Right, so that's our answer for part B. Okay, thirdly, given that the sum from 1 to n of this is 186, find the value of n. Okay, so this seems like your cookie cutter solve a quadratic equation question. So this is C. We know that the sum to n is 186. So we will use our formula for the sum to n over 2 times 3n minus 5 is 186. Oh, sorry, this is meant to be a 6. And we multiply this out, multiplying the n over 2 factor to every term in this bracket. So we get 3 over 2n squared minus 5 over 2n is equal to 186. And at this point, for readability, I'm going to multiply everything by 2 before moving this to the left-hand side. So we get 3n squared minus 5n is equal to, or rather, minus 186 times 2, which is 372, is equal to 0. So, what do we do from here? Well, one thing, of course, would be to try and factor this by grouping. And of course, this may not be the best idea because we are working with such a ridiculously large number here in terms of trying to find its factors. Like, you would be trying to find the factors of negative 1116. So I think the best thing to do here would just be to use the quadratic formula to solve this question. So what do we have first? We have using the quadratic formula, n would be equal to negative b, so 5 plus or minus the square root of b squared, so 25 minus 4ac. So minus 4 times positive 3 times minus 372 equates to plus 4464. So, and then finally it's all over 2a, so 2a would be 6. So of course 4464 plus 25 is 4489, and we want to take the square root of this. This is of course using a calculator, and it's 67. So it's 5 over 6 plus or minus 67 over 6. And we know that because it's the index of a series, n has to be greater or equal to 1, and n must be an integer. Therefore, n must be equal to the positive version of this, 5 over 6 plus 67 over 6, which evaluates to 72 over 6. And of course this cancels out to n equals 12. Right, so rounding that question off quite a timely manner. Or in fact, just before reaching the end of the paper. Alright, so I'm going to consider this question done and move on. Alright, this is a kinematics question, so it will involve calculus, topic 9 calculus. So I'm going to write down the timestamp as 27 minutes. So question 5, 9 marks. Calculus / kinematics. Okay, kinematics is just a fancy word they use in the syllabus when they're describing like the movement of particles along a straight line. Alright, so question 5. A particle P moves along the x-axis at time t seconds. The velocity of P is 5 cos 2t. Oh my goodness, this is quite the particle we have here. So, first we must find the least value of t, for which P is instantaneously at rest. Okay, so we know that t is going to be greater than or equal to 0, and we're looking for it instantaneously at rest, so v must be equal to 0 in this case. So if v is equal to 0, 5 cos 2t is equal to 0, where t is greater than or equal to 0. Right, so cos 2t equals 0, dividing both sides by 5. And of course, if you remember, for a cosine to be 0, you're going to want to have your angle here to be pi over 2 radians. So, in this case, the smallest number we can get where cosine is 0 would be pi over 2. So, 2t is equal to pi over 2 seconds. Then we get t is pi over 4. Okay, so important thing to note, when they are using trigonometric functions in a circumstance that is not related to actual geometry, generally the input will always be in radians and in terms of pi, not degrees. There's no radian unit here. It's just the time in seconds, so it would act as if it were radians. That's how it works. Okay, so the magnitude of the maximum acceleration of p. In this case, we want to find an expression for the acceleration, which would be given by differentiating v with respect to t, and then finding the maximum of that. And given that that's a trig function, the differential is probably going to be another trig function, and we can just find the amplitude of that just from whatever numbers back there, because of the range of the trig functions are always just between -1 and 1. Alright, so question 5b. Acceleration is equal to the derivative of velocity with respect to time, equals d by dt 5 times cosine 2t. Alright, so because there's a 2 in there, we're going to have to use the chain rule, unfortunately, which is a bit annoying. It's a bit annoying, but we'll survive. So let u be equal to 2t. V is 5 cosine u. dv by du is minus 5 cosine u. And du by dt is just 2. And dv by dt is dv by du multiplied by du by dt. Like this fraction and this fraction cancels out because they're the same infinitesimally small change in u, which would be equal to minus 10 cos u, which would be equal to minus 10 cos 2t, making the substitution to get back to the t world. Yeah, okay, so this is not cosine, this is 5 sine u. Grave mistakes are being made. Okay, the differential of cosine is going to be negative sine. That's pretty important to remember. Anyway, you get minus 10 sine 2t is the acceleration. The maximum of minus 10 sine 2t will be 10 meters per second squared, because it's multiplied by negative, and the minimum of sine theta is minus 1. Therefore, when sine 2t is at minus 1, for example, at a point where we have the 2t being equal to 3 pi over 2 seconds, we will get the minimum value of minus 10 sine 2t, which would be just positive 10 meters per second squared. Alright, so finally, when t is 0, p is at the point 2, 0. Right, so it's moving along the x-axis, it's 2 meters from the beginning of the x-axis. Find the distance of p from the origin when p first comes to instantaneous rest. Okay, so distance is going to be the integral of velocity with respect to time, or it will be the integral of 5 cos 2t dt. And this would be, or we can move the 5 on the outside because it's a constant, and we're going to have to reverse chain rule this. It's going to be 1 over 2 sine 2t. So we end up with 5 over 2 sine 2t, because you can see if we differentiated it, this 2 would multiply back out and we'd be left with the whole 5 as our coefficient that we had in the first place. So 5 over 2 sine 2t plus c. And of course, since P starts at x equals 2, plus c must be equal to 2 meters. Therefore, the distance is 5 over 2 sine 2t plus 2. And of course, if we substitute in the value of t being equal to, if we look at our previous answer for the time at which p is instantaneously at rest, it's pi over 4. Seconds. So you get d is equal to 5 over 2 sine pi over 2 plus 2, and sine pi over 2 is going to be equal to 0. Actually no, sine pi over 2 is going to be equal to 1, right? So it's going to be 5 over 2 plus 2. And in this case, it'll evaluate to 9 over 2 meters. That is the displacement from the origin when it first comes to instantaneous rest. Now you might be wondering why I did not use a definite integral from 0 to pi over 4 seconds. And the reason I did not use that kind of integral is because it would have given us a result which is just the amount of movement that it had, not necessarily its current position. So by creating this expression for d on any t and taking the plus 2 into account, we have managed to correctly find the actual position of it on the x-axis rather than just how much it's moved from its original location. Alright, so I'm going to consider this question done, and we are moving on to the last two. Alright, so this one's trigonometry. I will write this down as 37 minutes in. So 37 minutes in, we have a trigonometry question. Question 6, 10 marks, trig. So, figure 1 shows triangle ABC, which looks quite flat, with AB is 10, BC is 6, and BAC is 28. The point D lies on AC such that BD is 6 centimeters. Okay, so instantly we know this is an isosceles triangle. Don't know how that's going to help us yet, but it's something we do know, and it might be useful later. So, find to the nearest 1/10 of a degree the size of angle DBC. So we want to find this angle here. Right, so where shall we start? The first thing we could do would be, I suppose, to try and find this angle here using the sine rule, because we have this angle and the opposite side, and we have this opposite side but not this angle. And once we have this angle, it's 180 minus 2 times this angle to get our top angle. Alright, so first we shall venture to find the angle BCD. So using the sine rule, we would know that sine 6, or rather sine 28 over 6 equals sine angle BCD over 10. Because this is following the sine rule, we might want to mention that we are using the sine rule here. So sine rule where .28 is the angle BAC, 10 is AB, and 6 is BC. And finally we get that sine BCD would be, well, when we multiply both sides by 10, we'll get 10 over 6 sine 28. And this evaluates to 10 divided by, oh dear, the calculator's not working. 10 divided by 6 times sine 28 degrees would be 0.7824, so on. It's always safe to use a large number of decimal places for functions like these, because you want to make sure that the angles you're getting out of them are accurate in order to get your accurate calculation. So 0.782456, that's how much I'm going to write it to. So sine BCD is this. So we're saying we're applying the inverse sine function here to get that BCD must be equal to, in this calculator, it's just sine -1, and then the answer 51.48 degrees, or 51.4856. And so on degrees. Right, so again, this is to a large number of decimal places just so that we can get our accuracy we want in order to have extreme confidence that this will be to the nearest 0.1 degrees. Alright, so actually in this case you can just keep using your calculator accuracy by doing the operation using the ANS button, like capital A followed by lowercase n, lowercase s, meaning answer, which we use the exact value of the number you just calculated. So anyway, because we need to show our reasoning, BD is BC, therefore BDC is isosceles and additionally BDC and BCD are equal. Therefore, the angle CBD that we are looking for, or rather it's shown as DBC, guess it wasn't legalized yet, will be 180 degrees minus 2 times angle BCD, or 180 degrees minus 2 times 51.4856 ... degrees, which works out to 180 minus 2 times answer 77.0 degrees to 1 decimal place of accuracy. Right, so that's our final answer for part A. Find to 3 significant figures the length of AD. So I am guessing here that we might want to be using the cosine rule. Right, so it's c squared. Okay, let this be c squared is a squared plus b squared minus 2ab cos c. So the missing link is this angle. We want to know what this angle is so that we may figure it all out, because otherwise I don't think it will be possible. Right, so how do we get to this angle? Or in fact, is there a simpler way of getting this side length? We know there may be two ways you can make a triangle with these two sides and this here. So, of course, there will be two side lengths which are possible if we try and evaluate it this way, which means that there likely isn't going to be a direct one single step to finding the value of this side. So what I'm going to do here is just try and find this angle, which will be 180 minus 28 minus whatever this angle was, minus this angle, 77.0, or in our case on our calculator, 77.02, blah blah blah, to find this angle here. So this is question 6b, and we are trying to find angle ABD, or ABD, that is. So angle ABD is 180 degrees minus angle BAD minus angle DCB, and finally minus angle DBC, or 180 minus, well, we know that BAD is 28 degrees, DCB is 51.4856 blah blah degrees, and DBC is 77.0286 degrees. Again, we want to be as accurate as possible here when we are trying to get some length to three significant figures. So this will be 180 minus 28 minus 51.4856 minus 77.0286 to get 23.4858 degrees. And of course we can actually, we're not going to round that because we're going to try and keep accuracy until the end when we round the length we're trying to get. So at this next point we want to find our distance AD. So using the cosine rule, AD squared is going to be DB squared plus AB squared minus 2AB DB cos 23 point something something degrees. So we write this all out to let the examiner know that we have applied the formula. And of course we are going to substitute our known side lengths in, so 10 cm, 6 cm, and finally at this point I think we can just evaluate it without showing arithmetic. So it's 100 plus 36 on the calculator minus 2 times 6 times 10, so minus 120 times the cosine of 23.4856 degrees, which brings us to 25.9407 is the square of AD. And so AD will be the square root of this number, so square root answer, which would be 5.09 centimeters. three significant figures. Alright, so now we know there's 5.09 centimeters to three significant figures, which is what we were asked to get. And finally, it's find to three significant figures the area of triangle ABC. So that's this entire assembly here, the entire triangle. Alright, so the most obvious thing that occurs to me right now is to use the sum of these two angles to show what our final angle in that corner of this enormous triangle is, and use the area equals half AB sine C formula in order to find the area in the end. So answering question 6C, we actually don't have a lot of space left, but that is okay, we try our best. Area equals half AB sine C, and C is equal to the sum of those two angles, so it will be 77 point, this time I wouldn't do it too much accuracy, C is 77.0286 degrees plus whatever that other angle here was, 23.4856 degrees. So overall that adds up to 100.5142 degrees. Now honestly, you could probably get away with one less decimal place and one less significant figure, and there's probably no use to doing it at this precision. But I suppose if you want to be, it just depends on how confident you want to be for answers to three significant figures. Because if you can save time at other parts of the test, that may be easier. Because like for me, always trigger takes the longest time. It would be better for you to try and get the accuracy marks here. Okay, so A would be half times 10 times 6 times sine of 100.5142 degrees. And this would evaluate to 0.5 times 10 times 6 times sine 10.5142, which leads us to 29.496 centimeters squared. Now this may seem kind of counterintuitive given that it's already not much, like these side lengths seem so long compared to that kind of area, in my opinion at least. But I feel like it might be about right, because 28 degrees off the ground would give this level here to be around maybe 5 cm. And if this is 5 cm, this kind of looks similar, so maybe, I don't know, another 6 or 7 cm, then I'm not surprised actually, because it would be 5 times maybe around 10, and halved would be around 25, and of course this might be more than 10. So in actual fact, it does seem like a rather realistic calculation for the area. So I'm going to write that as our answer: 29.5 centimeters squared to three significant figures. Right, so that is question 6 done. I will consider that done. And finally, we have question 7, which is a question about the Cartesian coordinate plane. It's made up of 5 questions, each worth 2 marks, so that shouldn't be too hard to deal with. So I'm going to write the timestamp as 54 minutes into the video. Question 7, 10 marks, the Cartesian coordinate plane, CCP. The acronym has other meanings, but if you don't live where I live, it might not have a meaning to you. Anyway, question 7. The point C with coordinates 2, 1 is the center of the circle which passes through the point A with coordinates 3, 3. Find the radius of the circle. Right, 7A. This is quite the thinking I have to do because I have not encountered a question with circles before. But given that it's the center of the circle and point A is a point on the edge of the circle, the distance between them must be the radius. So to find the radius of the circle, it should be quite easy. So r is the distance AC. And using the Pythagorean theorem, well, first our delta x squared plus delta y squared. So our delta x, the difference in x coordinates would be 3 minus 2, which is 1. So 3 minus 2 squared plus, then the y coordinate is 3 and 1, so 3 minus 1 squared should be 1 squared plus 2 squared, or 5. So if AC squared is 5, then the distance AC equals the radius, which must be equal to root 5. Right, so the line AB is the diameter of the circle. Find the coordinates of B. Okay, so given that AB is the diameter of the circle, and like if we make our little diagram here, the point C with coordinates 2 and 1 is the center of the circle, which passes through point A with coordinates 3, 3. So if this is 3, 3, this is 2, 1. Now, given it goes down 2, we'd expect it to go down 2 again. And given it goes left 1, we'd expect it to go left 1 again. In other words, the vector from A to C is the same as the vector from C to B. And we can sort of write that as our proof of this, to be frank. So, B lies on the line AC. In fact, the vector from AC is equal to the vector from C to B. That is to say, this is not an English test, 2 down, 1 left. Therefore, applying the translation of 2 down and 1 left to C, which is at the coordinates 2, 1, will give B. Thus we know that B must be equal to, well, first the x is moved, right, 2 down, 1 left, the y must go on the bottom, so it's minus 1 and minus 2. So anyway, 2 minus 1 and 1 minus 2, because that is applying the vector from A to C. Like, I apologize if it's a bit confusing to be talking about vectors, but basically, the journey you take going from A to C is just extended the same distance going from C to B. So we can take the difference in x and y from A to C and apply it to C again to get our point for B, since a diameter is just the radius repeated in the same direction, in the same length. So B is 2 minus 1 is the x and 1 minus 2 is the y, which would be 1, positive 1, and negative 1. So, yep, we did find the coordinates of B like asked. The point D with coordinates 0, 2, and E with coordinates 4, 0 lie on the circle. Show that DE is the diameter of the circle. Alright, so I think we'll need to show that DE passes through the point C. So what we could do is we could find an equation for the line DE. So the gradient of the line for DE would be equal to the rise over run, or in fact the 0 minus 2 over 4 minus 0. Which is minus 2 over 4, which would be negative a half. So that's the gradient of our line DE. And secondly, the y-intercept for DE, or rather the line DE, we know it has to pass through D, which would be the coordinates 0, 2. DE leads to 2 being equal to minus 1 over 2 times 0 plus C. Therefore 2 equals C. So thus we know the line DE is y is equal to minus 1 over 2 x plus 2. And so we have to show that the point C lies on the line DE. So if we sub the x and y values from point C, which is the center of the circle, we have our y value being 1 must be equal to negative 1 over 2 times 2, which is our x value, plus 2, or 1 is equal to minus 1 plus 2, 1 is equal to 1, which holds true. So DE passes through the point C. And we can say that DE is the diameter of the circle. Right, so that is part C of the question complete. We have proven that DE is the diameter of the circle by showing that it passes through the center of the circle. The point P has coordinates x and y. Find an expression in terms of x and y for the length of CP. Alright, so we know it's going to be the delta x square, the square root of the delta x squared plus the delta y squared. So 7D. CP is going to be, or CP squared in fact is going to be the delta x of CP squared plus the delta y of CP squared. And the delta x is going to be x minus, where x is our p's coordinate, and the x value for the point C would be 2, if I'm not mistaken. So it would be x minus 2 squared plus y minus 1 squared would be our CP squared. And thus we can show that CP, the distance CP, will be the square root of x minus 2 squared plus y minus 1 squared. Alright, so that was fairly simple as far as it goes. And given that the point P lies on the circle, show that x squared plus y squared minus 4x minus 2y is equal to 0. Alrighty, so if it lies on the circle, then it must have a distance that is equal to the distance of the radius. So CP squared must equal the radius must equal, or rather CP squared must equal the radius squared must equal root 5 squared must equal 5. So, how do we put this into equations? X minus 2 squared plus y minus 1 squared must be equal to 5 for P to be on the circle. And so if we expand those two brackets out, I suspect that we will get an equation that cancels out to this. So, first we have x squared minus 4x plus 4, which would be x minus 2 squared, plus y squared minus 2y plus 1 equals 5. Or x squared plus y squared minus 4x minus 2y plus 5 is equal to 5. And you can kind of see how things are falling into place here. You subtract 5 from both sides and you get x squared plus y squared minus 4x minus 2y is equal to 5. Or rather, you subtract 5 from both sides, you get 0. So, we've proven this equation to be true, and this question can be considered complete. Alright, so that is the end of the video for now. It has been quite the session of FP Math, and I will probably be making another video containing the last 4 questions of this paper, which is the other 50 marks, in the future. Alright, so thanks for watching.